All right, I'm going to put a minute for you guys to watch the video if you haven't already started. On your markers, go. Video link is in the chat, or you can watch it on Pear Deck. So if you didn't watch the video from the link that's in the chat, that is on you. All right, so we had the sea of electrons. So what happens with the metals is that these electrons get shot off of the atoms and they're just kind of floating around in what we call delocalized electrons. So delocalized means that they're not localized where they used to be. They're somewhere else. And so the electrons just kind of move around. And so because these electrons can move, do you think that's going to make something more bendable or less bendable? I'll give you 30 seconds. I don't think 45. Why are these things bendable? Why can we bend metals, but we can't bend non-metals? What about the electrons makes them bendable? What happens to those electrons?
Eliud, you better be on Pear Deck.
I don't see him here. There's no pumpkins yet. Oh, there he is. He hasn't responded. All right. Ashley Garduza, can you come off mute and tell me what happens to electrons?
They move around.
Yeah, they do. Thank you. Moving on. Again, okay, that was the end of the story for metallic bonds. Literally, all you got to know is that the electrons move around. Covalent, this is like one of the harder concepts that we're going to talk about. So if you don't get it today, that's okay. Do your best. We're going to do a whole practice day on Monday. So can I get a volunteer to remind us who Linnaeus Pauling is? Go ahead, Allison.
The first one?
Yeah.
Okay. Electronegativity. Electronegativity, as defined by Pauling, is the power of an atom in a molecule to attract electrons to itself.
Absolutely wonderful. So we talked about this guy, but if you forgot about him, understandable. He was the one that discovered electronegativity, which is how well atoms attract electrons to themselves. And that's important, what we're going to talk about. So, what does it mean if electronegativity, or fluorine is the most electronegativity negative element? So even I'm struggling with this. If you're struggling saying electronegativity, don't feel bad. So I'll give you a minute. We'll see if we need the other 30 seconds or not. What does it mean that fluorine is the most electronegative? Looking good. Rain. Hilary, Jose, Ashley, Kimberly, Eliud, Monte, Anthony, Michael, Atlanta, Samantha, Ricardo. That's just the first column. Looks good. Derek, I don't remember if your microphone works or not. I would like to call on you if it does. Looks good, Elena. Looks good, Amy. Perfect, Jacqueline. Monse, if Derek can't come through, I'm gonna call on you. All right, Derek, you there?
Yeah.
All right, what you got?
I said that fluorine is the most active or most electronegative element because it wants valence electron to fill its outer orbital.
Absolutely perfect. Thank you, thank you, thank you. So because fluorine's the most electronegative, he wants electrons. Like really wants them. So yesterday we talked about the ionic stuff. Today we're talking about the covalent stuff, which is on the other side of the spectrum. Alrighty, where on this periodic table are the nonmetals? 30 seconds. Draw, 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 draw. Jason, Samantha, y'all good over there? Good, Diana. Good, Geraldo. Chris, other side. Johanna again, fancy labeling nonmetals and metals. Let me find you. It says response deleted. Alrighty. Who wants to tell me where are the nonmetals? Volunteer 1. Volunteer 2. Go ahead, Allison. Are they on the right or the left?
The right.
Yes. Yes, they are. So everything that we're talking about is going to be elements on the right side of the periodic table. Samantha, you know I can see you, right? And Diana and Yesenia. I don't know if we're on our phones working or doing all our stuff, but I can see you. All right, who's going to read to us about the octet principle? Allison, you already read. Baylin, are you here?
Yes, I'm here.
You want to read that slide for me?
Sure. Recall octet principle, any p and s sublevels are filled with a total of 8 electrons. The atom will do what is easier to end up with in a filled energy level. Don't worry about middle elements. Sublevels D and F are complicated.
Thank you, thank you, thank you.
Welcome.
All right, so in covalent bonding, our atoms want to get a noble gas configuration, so 8 valence. You know that, we've talked about that. But because they're so electronegative, they're not willing to give up an electron, so they're going to share an electron pair. So they're not taking electrons, they're sharing them. And when they share electrons, that's when we call it a covalent bond. So the prefix co means to be together or to share. And so if you're covalent, you're sharing your valence electrons in a bond. Now, wait a minute in case any of you guys want to take a picture of this slide or want to take a note or two. Alrighty, 1.5 minutes to find the covalent molecules. They should be able to interact with the periodic table at the same time. So the covalents only have non-metals on your mark. Set, go. So just make a note of it. If you want to put it in the chat, you can, just because you can't draw and look at a website at the same time. If you want to put your answer in the chat, you are welcome to do so. Who is covalent? Good job, Johanna. Thank you for your participation. And so our covalent ones, if you didn't get it from the circles, if we look, oxygen's a nonmetal, hydrogen's a nonmetal, nitrogen's a nonmetal. Lithium, sodium, calcium are all metals. So those would be ionic. Metal, nonmetal, ionic, nonmetal, nonmetal, covalent. Alrighty, I'll give you 1.5 minutes. Look at these pictures. What differences do you notice between the ionic and the covalent in these pictures? The red one is the covalent, the blue one is the ionic. And what differences do you notice? Johanna, I like your answer, but I think covalent and ionic are backwards. Alright, Celeste, you got a good one. You think you can come off mute and share? Celeste 1, Celeste 2, Celeste 3.
I said that ionic has a line which indicates that an electron is being transferred, and covalent shows the elements being sharing electrons.
Absolutely perfect. Thank you so much. Alright, so if you're a prime person who wants to see this in words, Mr. Boyd, will you read the stuff on ionic bonds?
Yes. I think, okay, there it is. Electronegativity is so different. Electrons leave the least electronegative atom, the metal. Electrons go to the most electronegative atom, which is the nonmetal.
Thank you very much. And who wants to read about the covalent bonds?
I nominate John.
You hear, John? John 1. John 2. John 3. No, John.
Well, I saw Jacqueline's hand. Jacqueline, go ahead.
What am I reading?
Covalent.
Covalent bonds, electronegativity is similar, so electrons can't leave. Electrons are shared between the atoms in bonds.
Thank you very much. And so again, this is super important to know the difference. So if you're going to make flashcards or something, make one off of this. And here's a picture to help you remember. So the covalent, it's like the two atoms are having dinner and they're sharing food, and there's the food is the electrons and they're having a swallow time. And the ionic is a much stronger bond. It's like getting married, and so he's actually offering the electron and saying, take this, be ionically bonded to me forever because you have my electron. All right, what are the two main differences between covalent and ionic? 1 minute and a half on your mark. Get set, go. Welcome back. Jose Rico, we just talked about this. And you could look at the meme. Obviously, the covalent shares electrons. What's the opposite of sharing? Use the meme. Look at Estrella with that photographic memory. Excuse me, Caden. So if you forgot, the covalent share electrons, the ionic don't. One of them deals with metals and nonmetals. The other one is nonmetals and nonmetals. If you're trying to figure out the second difference. Dang, Celeste, I should have called on you this time instead of the other time. Another good answer. There you go, Jose. That looks better. Chris, I don't know what you're talking about there. Looks good, Amy. Alrighty, our minute and a half is up. So our two things. One thing is who's involved. Metals and nonmetals for ionic. Nonmetal for covalent. The second difference is what happens to the electrons. Ionic is taken, covalent is shared. All right, now we get to the juicy stuff, the complicated stuff. So if we have two nonmetals, figuring out the bond's not that bad. We'll draw the dot structure. If you forgot how many dots, it's the valence. If you forgot the valence, it's the number at the top of the column. Should always be less than 10. We want to know how many electrons does everybody need to be happy. Remember, we talked about that octet principle. Everybody wants 8. And then we just connect the dots. So, for example, we got chlorine here. Chlorine's got a valence of 7. So it needs 1 more to get to 8. And so each one of them wants 1 electron to fill the valence. But they don't want to give it up because they're super duper duper electronegative. And they're like, I'm hungry for my electrons. I ain't ready to give this up. And so we got to figure out what's going to happen. So we got these high-tech animations of our chlorines coming together. And hey, look, now the one on the right has 8 valence. The one on the left has 8 valence. So these 2 electrons in the middle are shared, and we show this with a line. So if you see a single line, that indicates 2 electrons are there. 1 line, 2 electrons. One more time, just so we're clear. One line, 2 electrons. And so we call this Cl2 because we got 2 Cls, 2 chlorines. Alrighty, so what does the line between 2 atoms mean? 1 minute. You got this, go. Get it, go. Yeah, Johanna. Yeah, Allison. Yeah, Samantha. Yeah, Elena. If your name is Lara, what are you doing in that room? Jose, Kimberly, Eliud, Monse, Geraldo, Michael, Elena, Parsenius, Ricardo, Brian, Abril, Luis, John, Aurelie, Chris, Lennon, Natalia, Genesis, Raylan, Rihanna, Asia, Francisco, Jocelyn, Isaiah, Yesenia, Natalia, Arturo, Elizabeth, Maritza, Eric, Brian, Justin, Ruby. One line means what? Good, Jose. Good, Maritza. Good, Jennifer. Damaris, I'm gonna call on you. What you got, Damaris? Damaris 1. Damaris 2. Damaris 3. No Damaris. I'll do one more, maybe. Chris, what's our answer? Chris Alberto. Chris 1. Chris 2.
Hello?
Eat.
Do I say it?
Yeah.
I put 2 shared electrons.
Yeah, it is. That line means 2 shared electrons. Good job. So, moral of the story. Does someone want to read the moral of the story before I read it? Go ahead, Celeste.
Moral of the story: electrons don't like to be single. They like to date, to be together and bond. So it's our job with covalent compounds to hook the electrons up with each other. Yes, that's right. We are the date masters, but we are fair date masters. We don't like electrons to go unpaired.
Thank you, thank you, thank you. Alrighty, so I'm giving you a chance to try this. Number 1, you're going to have to draw oxygen 2 times because there's 2 of them. If oxygen has a valence of 6 electrons, how many does it want to share? Once you've figured that out, connect that many dots, or that many pairs, excuse me. Alrighty, what did we say? 2 minutes. On your mark, get set, think about it, go. So we can tell from that picture that oxygen has 6 valence, so you need 6 dots around that oxygen. So you should have 2 oxygens. Oh, Elena, you are so smart. Beat me to the punch. You figured it out. So did Abby. Too smart. Kind of, I think. I think I know what you're trying to do there. Touche, Isaiah. Using the oxygen that's there to put your dots on. Looking good, Brian. So once you have your both oxygens that have 6 dots around them, oxygen's got a valence of 6. It wants 8. That means it needs to share 2. So you're probably going to have 2 lines connecting the 2 oxygens. And this is going to be very common with oxygen. It loves to have 2 bonds. So instead of 1 line, we might see 2 lines in the middle. Anthony, I don't know where you got that 3rd oxygen from. We only got 2 of them. Kind of, Allison. I'll show you exactly what I mean in just a minute. That looks really good, Ashley Garduza. That looks really good, Johanna. And we are out of time. Not at the class, just on this question. I wasn't planning on it, but I can help you if you need it. Alrighty, so the big reveal. How will the two oxygen bonds bond? So we have these unpaired electrons. If you didn't draw it that way, that's okay. But this is one way to draw it. It's technically how you're supposed to draw it. We can review that on Monday. So this one is going to pair with the other one. We're going to move closer and closer and closer. And so they want to share 2 electrons because they got 6 each. And they're going to keep getting closer. And then these electrons get so close that now oxygen has 8 in its valence. And the other oxygen has 8 in its valence. And we got a double pair, which means that we got a double bond. 2 lines, double bond. 3 lines, triple bond. There's never going to be more than 3 lines. And O2 is actually what we're breathing right now. We don't breathe oxygen by itself because it likes to have this double bond. We are inhaling O2 right now. All right, 30 seconds. How many electrons are shared in a double bond? Go. Yes, Derek. If you forgot, remember 1 line is 2 electrons. If you have 2 lines, how many is that? Samantha, what's our answer?
4.
Yeah, it is. Good job. 2 lines, 4 electrons. Good job. All right, this is the hard part. This is the hardest part of the day. So if we have more than 2 atoms, this is a little bit tricky. It's going to look something like this. You're going to start off with this picture that has all these dots, and then you're going to finish it with a picture that just has lines. Alrighty, I'll read step number 1. I'll call someone to read steps 2, 3, and 4. So step number 1, the least electronegative element goes in the middle. Your least electronegative, if you forgot, will always be the furthest from F. Always the furthest, but never, never, ever, ever put H in the middle. Hydrogen will never, I promise you, never in a million years be in the middle of a multi-atom compound. Can I get someone to read the rest of the steps? Need a reader for steps 2 through 5. Go ahead, Amy.
Add valence dots around the central atom. Write in other atoms around central atom. Draw in valence for other atoms. Determine how many electrons need to be shattered to satisfy the octet principle.
Thank you, thank you, thank you. And then the last one, we'll connect the dots. So, before we get started drawing pictures, why do you think the least electronegative atom goes in the middle? On your mark, get set, go. So remember, electronegativity is an affinity for electrons. They attract the electrons. So if you are the least electronegative, you do not attract electrons very well. Good, Isaiah. Celeste on fire. That's good. Ashley, to Kaylin, I'm sorry. If you're at home, maybe take some ibuprofen. Celso, I'm probably going to call on you in 20 seconds. All right, Celso, what you got?
But they want the least amount of electrons, so they would share the electrons with other elements.
Absolutely perfect. Thank you. And so what we said is that most electronegativity means that they have a high affinity, so they want the electrons. The least electronegative doesn't have a high affinity, so it's a lot better at sharing because he's not hungry. He's like, I'm already satisfied. I'm not electronegative, so I can share. So that's why he goes in the middle. Alrighty, so why do you think H, that should say never goes in the middle? Why doesn't H ever go in the middle? That makes sense too. On your mark, say go. Why doesn't H ever go in the middle? How many electrons does hydrogen have to share? And is that enough to share? Okay, good. So if hydrogen only has one electron, can I share with 4 other atoms? Okay, then we're always going to pick on hydrogen. He's a weirdo.
Miss J, 5
Yes.
minutes left, and please download your attendance.
Thank you. Alright, who's gonna be allocated? Oh no, she doesn't do Mike. How about Maritza Aguilar?
It only has one electron, so it is not enough to share.
Perfect, 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 and I appreciate the echo. It happens. Alrighty, so just like Maritza told us, hydrogen ain't never gonna be in the middle because he only has one valence. And you can't share one electron with 4 atoms. The mass ain't there. But don't forget hydrogen, you're the number 1 element. Because it's number 1 on the periodic table. Alright, we'll do this one together. So step 1, if we're comparing nitrogen and fluorine, who's the most electronegative? Draw that element in, and if you're feeling fresh and you can do the valence, do the valence. If you forgot the valence, that's okay. Just tell me right now who's going in the middle. Marcus, say go. Is it going to be N or F? Not NE. We're not talking about NE here, just N. So we'll look to the left of fluorine. Look at Johanna. Just going, going, going. So if we're going to compare N and F, who's further from F? Hint, hint, F probably isn't going to be in the middle. I don't know why we're circling B. We're talking about N for nitrogen. I don't know where we're getting boron from. We've got our examples NF3. So yes, boron is more electronegative, but we're talking between N and F. All right, Abby, who's it going to be? Who's in the middle?
Nitrogen.
Yeah, it is. Good job. So we got nitrogen in the middle. So I'm going to give you 30 seconds to put the valence. Marcus, go. So this says 15. Pretend that one ain't there. And give me 5 dots. Looks good, Abdon. Let me finish my class up. Let me wrap up my class. Looks good, Amy. Asael, the dots go with the N, unless you're going to draw in an N. And that looks good, Elena and Celeste. All right, here's the great reveal. So we got our 5 dots on nitrogen. So now I want you guys to draw in the other 3 fluorines and try drawing fluorine's dots. Hint, hint, fluorine has a valence of 7, so it's only going to want to share 1, so you probably want to put it on the sides that only have 1 dot. Looks good, Abby. Looks good, Celeste. Good, Johanna. Allison, we're using F, not CL, but that's good. Kimberly, your F should be around the N. That looks good, Derek. Looking good, Kaden. Looking fancy, Jose Romero. Good job, Ashley Garduza. If you don't have time to put the dots, at least put the Fs. Looking good, Salso. Alrighty, for the sake of time, if you didn't finish, that's okay. I'm going to show you what it should look like. Should look something like this. Obviously, if it doesn't, if you're similar, you're good. So we got fluorines on each side, and they're near the electron that I make the bond with. I'll teach you how to do that on Monday. Don't freak out. So the last step for the last part of the day, connect the dots. Make the bonds. And then once you make your bonds, and we'll talk about the math on that on Monday. And I am out of time.